This recording is meant to basically give y'all a refresher on what we did a little bit on Friday before we left. Y'all know that these are the formulas that I gave y'all, and now you have to memorize. Okay, we practiced a little bit of them. What I'm going to do is have you take notes on 4 problems so that tomorrow when we come to school, y'all will be like just ready to practice in class. We won't have to take notes. We'll just ready to go. So here are the formulas. You take a minute to copy them down. Don't forget your delta x over here. It's always the same. Okay. All right, and so let's move on. Okay, so messed up my first example. Let's go to my example. 1's on the bottom. Sorry. Okay. Note, you do not need the graphs on these. Once again, let me say, you do not need the graphs on these. Where'd my pen go? Oh boy. Pen. Sorry about that. Well, okay, you don't need the graphs, but I'm going to draw them because the graphs really just put things into perspective. So this is an LRAM 3 to 6 intervals. The first thing we need to do, and then we'll tell if it's upper or lower. First thing we need to do is find delta x, and this is a and b, so b minus a, 6 minus 3 divided by 6. That's 0.5, 3 divided by 5, okay? So let's go ahead and put these on there. 3 to 6, 6 subintervals, and it's an LRAM, so we're 0.5 wide. It's an LRAM, so we're hitting on the left. So there you go. Okay, there you go, and we can label x sub 0, x sub 1, x sub 2, x sub 3, x sub 4, x sub 5, and x sub 6. And the reason that's x sub 1 and not x sub 0.5 is because your delta x is 1/2, it's 0.5, so that makes that delta 1. Okay, so this is the first thing you do. Calculate that. Second thing you do is calculate your x of I minus 1. I got all kind of papers underneath here. So a is 3, delta x 0.5, I minus 1, so x of I minus 1. Oh, sorry. 3 plus 0.5 I minus 0.5, x of I minus 1, 3 minus 0.5 is 0.5 I plus 2.5. I don't mind if you use decimals every now and then. The next thing we're going to do is calculate the f of x of I minus 1. So in order to do that, first we need to know what f of x is. So f of x is 2x plus 3. Okay, so that we're going to actually substitute x of I minus 1 in there. So the whole thing goes in there. 2, don't have white out, 0.5 I plus 2.5. I'll rewrite that. Okay, so sorry, I have to write in pen because pencil doesn't show up really good on video. Okay, so there we go. Plus 3. Now we simplify. And there we go. Amazing. So now we actually just write the formula and go with it. How many things are we adding up? 6. 6 rectangles. You see right here. And then I'm going to put that there, okay? And then delta x is just stay the same. Well, no, it won't stay the same. What was the delta x? It was 0.5, yes. So, all right, now don't distribute that because that is no, okay? Just trust me. Okay, so now all we have left to do is plug in 1, 2, 3, 4, 5, 6 and add everything up. And I'm going to do a little arrow and I'm just going to start adding. I'm plugging in 1 here, so I'll get 9 times 0.5 plus 2, 10 times 0.5 plus 3, 11. Whoops. Times 0.5. 4, 12 times 0.5. 5, 13 times 0.5, and 6, 14 times 0.5. Okay, so yeah, 1, 2, 3, 4, 5, 6. Clicking on 1, yeah, so that's good. And basically right here, right now, I can do something funky. I can take out the 0.5 and just add 9 plus 10 plus 11 plus 12 plus 13 plus 14. Okay, 14. It's a terrible 14. The pen's going crazy. All right, so that's 19, 23, 13 and 19, yeah? No, 13 and 14, yeah, 27. And then 19 plus 23 plus 27 is something. 42 plus 27, 67, 69, half of 69 equals 34.5 units squared. Now, why is this so awesome possum? Because it actually works. Okay, this actually works. Basically, this first rectangle is right here. If you plug in 3 into this equation right here, 2 times 3 is 6 plus 3 is 9. So this actually, that's 9 times a half. Okay, this actually worked. And this was 10 times a half. This actually works. So that's why it's cool. And you don't need a graph because notice I never referred to the graph at all. All right, so that's why this stuff is so cool, even though it's a lot of work, as you can tell as I pan out. Wow, wowzers. But it only took about 5 minutes, so we're good to go. All right, hopefully the rest won't take so long as well. The next thing we have to do is RRAM, but got a little twist on it, okay? Got a little twist on it. Let me move this out so I don't... All right, so cool. So here's your function. X squared minus 3x, that's what it looks like. We don't really need that though. RRAM, negative 1 to 1, 4 subintervals, that's all. Okay. Oh, forgot to answer the question. Is this upper sum or lower sum? We look at here, see the negative area. It's definitely going to be less than the real area under this line. So this is a lower. So we can circle that. Okay. All right, so we always start with our delta x, b minus a over m. So it's 1 minus negative 1 over 4. And we have another 0.5, okay? X of I. Now, RRAM is x of I. We have it on our formula sheet. So x of I is negative 1 plus delta x 0.5 times I. That's good. Now, we want to calculate f of x of I. In order to do that, we need to know what f of x equals. Well, f of x is x squared minus 3x. So if I'm going to plug in that, I'm going to have to square minus and multiply as well. So here we have negative 1 plus 0.5i. I'll rewrite that, sorry. And then negative 1 plus 2.5i as well. Okay. All right, so we've got a lot of work to do on this guy. Let me rewrite him though. I'm going to rewrite him right here. You got to FOIL this out. You got to do everything to it. So I want you to, beef up your algebraic skills on this. So we got to simplify it as much as possible. So that'd be positive 1 plus negative 0.5 negative I. So it's actually minus I, but that's okay. And then plus 0.25 I squared. Okay. And that'll end up being plus 3, and that multiplied minus 1.5i. Okay, well, right, when you distribute that, that's what you get right there. Bam, bam. Okay, so now I'll just combine like terms. Write it in standard form with the I squared first. These two combine, negative 2.5i. These two combine, 4. Okay? So now I just write my formula. I always start off with this. It's RAM, so it's f of x of I. And then I'm just going to fill in everything that I need to fill in. Okay? So I've got that. So let's plug it in there. Kind of running out of room. Well, how many things are we adding up? Oh, I didn't draw the graph. We have 4 subintervals, and it's RAM. So the graph is actually interesting because since it's an RAM, it goes up to here on the right, but then it can't go up at all. So actually it's a flat, nothing rectangle. And then here's 1, so the next RAM goes down. It's actually negative. It's a negative area. It's a negative area. And this one goes down as well. Okay, so that's negative area, positive area. What's the whole answer going to be? I don't know. Is it negative or is it positive? We'll find out. It's probably going to be negative. There's more negative area. All right, so let's plug it all in. 0.25 I squared minus 2.5 I plus 4 times delta x, which is 0.5. Okay, so get another sheet of paper because it's going to be a lot of calculating. I forgot to put my number on top. We're adding up 4 things. So basically I got to plug in 1, I got to plug in 2, I got to plug in 3, and I got to plug in 4. Here's a good trick. Take that 0.5 and take it out right now. So this is going to equal 0.5. See, I just took that 0.5 out of the equation. It's gone. Now I just have to worry about this. So I plug in 1. Those will stay 0.25 minus 2.5 plus 4. Okay? And since I've factored that out, I can just literally go ahead and start plugging in my next thing. And plug in 2, so 2 squared is 4, times 0.25 is 1. 2 times negative 2.5 is negative 5. 2 times... well, that doesn't have a 2, so that's just a x or a I. It's just a plain old 4. So I plugged in 1. I plugged in 1 right here. Plugged in 2 right here. I'm almost done. Let's plug in 3. All right, so 3 squared, 9 times 0.25. 0.25 times 9 is 2.25. So that's 2.25. 9 times 2.5 is... negative 22.5, yes, negative 22.5, and then got our 4. Almost done. Now let's plug in 4. Okay, so plug in 4. 16 times 0.25 is 4. Not 14, 4. 4 times negative 2.5 is negative 10. Okay, so we got our negative 10, and then we got our 4. So Factoring out that 0.5 really helped me a lot because now I don't have to deal with writing that 0.5 all over and over and over and over. All right, so basically there should be some easy steps to take to figure this out. So what I'm going to do is I'm going to take all my negative numbers and add them up first. Let's see, so 0.5, and that's negative 2.5. That's negative 22.5. That's going to make negative 25, negative 30, negative 40. All right. Take all my 4s. There's 4 4s. So that makes 16. And that's going to make 2.5 plus 1, 3.5 plus 4, 7.5. Okay, so did I get everything? Yeah, I did. Good. So I add all this mess up and see what I can get from there. So negative 40 plus 16, that's negative 24 plus 7.5. That comes down. Okay, so that basically becomes negative 17. Negative 17. No. Yes. No. Yes. No. Negative 16.5. And half of that is negative 8.25 units squared. Yes, you can have negative area. And your answer is negative. Okay? Now take a look at all that. Pan out. And zoom in. Well, it doesn't want to zoom. That's a lot of work, y'all, but as you notice, it only took about 8 minutes. Okay? I wish it would zoom a little bit better. You can see the first half of the work right there, the graph and the calculations. We're plugging in the 1, 2, 3, and the 4. I wish it would zoom. Okay, so let's move on to the next one. Actually, I'm going to pause right here and start uploading this video because I'm a little bit behind on the uploading. So